Hello! In this video we're gonna do some basic rendering using a sprite batch, and we're gonna do some basic input. But before we do that, I want to change this GL 2.0 bit to just GL. This GL also refers to a GL2 object, so the outcome is exactly the same as it was before. Now, on to rendering. I've taken the liberty to download a sprite from Pokemon Fire Red, and I can show it here. This is Red facing south and standing. We're going to render this sprite to the screen. We're here in game screen. We need to get the sprite loaded before we can display it. We're gonna load it in a texture object. We're just gonna call it player here. In the constructor we are loading this. It's very easy. And it's in the res folder, and it's called red south stand PNG. Great. Now to render this to the screen, we're going to use a sprite batch. Sprite batch is a small tool that will help us render sprites really fast to the screen, much faster than if we did it manually. Not without using some tricks. But the sprite batch does this for us, so we're just gonna take it. The batch is also really easy to initialize, just like that. Oh, and I realize I didn't explain why we do this every frame. Between frames, you want to make sure that the screen is cleared completely, and we do this by drawing a big black rectangle over everything, and that's what these two lines do. And we need to do that every frame, or else we can see the last frame behind the frame we're currently rendering, and we don't want that. So we could do this in the game screen. However, when I make another screen, like an inventory screen or something, we also have to do it. And with a lot of different screens, that means we have this command, or these two lines, in a lot of different screens. So I just want to do it here. The super render just calls the render method in the screen that is currently active. So this way we make sure that the screen is cleared every frame. Before we can render anything with the batch, we need to start the batch. We do that by calling batch begin. And when we want the batch to actually render everything that we've queued within it, we use end. Let's see if we can draw this texture now. We don't need all of these arguments, we just need a few of them. I'm just gonna delete everything there. I know the first argument is the texture, and then it's the X position on the screen, so we're just gonna render to 0. And the Y, and the width, and the height. And I know the width of my image here is 16, and I know the height is 24. Now when we run this, you see we actually have the player down here, and that's great. Notice that 0, 0 is the left down corner of the screen and not the top left corner like it is on the system. So it's a little bit different. Great. Before we move on to input, I want to make sure that we have a player object and that we can move the player. So I'm going to go ahead and create a new package called model, because I want this game to follow the model view controller design scheme. So let's make a player. Let's make a player. The player is defined by his position in the world for now, and that's it. So we're going to go ahead and generate a constructor using the fields. Great, there's no need to call the superclass constructor, and we also need getters. So we're going to select the getters here and generate those. Now I want to make sure that I can move this player around, so I'm going to make a little method here called move, and the arguments are going to be the change to the x coordinate and the change to the y coordinate. There we go. Now let's add the player in here. Oops. Maybe this texture shouldn't be called player. Maybe it should be called something else. Maybe it should be called red standing south. Standing south. Continue. Thank you. And the player can actually be called player now. Great. You also want to initialize the player here. We can just initialize him to 0, 0. Now instead of just drawing the sprite here, let's draw the sprite where the player is. So we still want to draw the same texture, but we want to draw it at a different position, depending on where the player is. Now since the sprite is 16 pixels wide, I have kind of decided that each tile in this game world is going to be 16 pixels. So I can take the player's x coordinate and multiply it by 16 to get the screen position of where he should be. And when we run it, we should see that he's still in the same position. Now, what if we change his position here? And he's moved. That's great. Now these 16s here are hard-coded numbers, and we don't really want those. So I'm going to go ahead and create a settings file or class with a few constant values in it. So we're going to have a public. I want to make sure that we can access these statically. Tile size. This is going to be 16. Oh, this is an int. Public. We also want to scale. And maybe this should be 2 actually. Maybe I want it a little bit bigger. And finally I'm gonna make it easy to get the scaled tile size. Scaled tile size, and that's gonna be tile size multiplied by scale. There we go. Now each time I want to scale everything to my world units that I've now defined to be 16 pixels, I can just multiply by this value. And now instead of defining the sprite's size, I can just define that the player is 1 scale tile wide and 1.5 scale tile size high. And that's a little bit better. We see the player still moved. So moving back to 0, 0 for now. Let's go on to input. I want this package to be called controller, because once again we're following the model view controller design scheme. Let's make a controller that can control the player. I'm gonna call it player controller, and libgdx has this wonderful way of making these controllers where you can just implement an input adapter. I believe it's implement. Nope, it is not. It is extends. It's a class, not an interface. How could I forget? But because this is a class, we can choose ourselves which methods we want to override. Now I want to know when someone presses the keyboard, and I want it to be the arrow keys. So I want the key down. Now that's returned false. In an input adapter, all these methods are booleans. The return type or the return value describes whether or not this input event was absorbed. Now, if I have a lot of these input adapters stacked on top of each other, then maybe I don't want the input event to go all the way down through the system. You can kind of think of it in terms of windows. When I click the window that is in focus, I don't want the windows behind it to also get the event. So the window in focus will or should return true because it absorbed the event. Now in this case, I don't want to absorb the event, or rather I don't care about it, so I just return false for now. Now I can check what key was pressed, checking if the key code matches the key for the up or the up key. Yeah, it's just the up key. And this is input. Great. And I want this for all 4 directions. Now in each of these cases, I want to move the player in the right direction. However, I can't access the player object from here. So I need to create a constructor where the player controller receives the player that it's going to control. There we go. Now I have access to the player. Now for the up, I want to move the player 0 along the x-axis, and I want to add 1 on the y-axis. And we do this for the other ones as well. There we go. Now in game screen, I haven't actually made a play controller yet, so let's do that. Great. Now when the game screen is created, we also create a controller. But we also need to specify to GDX that this is the controller we're going to use. We can do that by selecting that controller in the show method. This method fires whenever this screen is shown. So in our case, or in any case actually, when you change the screen that is being changed into fires the show method. We can set what input adapter is currently in use by calling GDX input, and then set input processor. And our adapter is an input processor. There we go. Now I can move our little player around. Great. Alright guys, that was basic rendering and basic input. I guess we'll have to see if there's gonna be another video.